Assalamu alaikum students. Hope you all are doing good. Today we'll start the third chapter of your physics grade 9 book that is about dynamics. So our objectives for today's lecture will be introduction of the third chapter, force, inertia, momentum, Newton's first law of motion, Newton's second law of motion, and then the summary. So I request you all to be fully attentive during the lecture. This time I have tried my best to make a lecture more interesting and comprehensible for all of you, as it is very important not only from your examination point of view, but also it forms basis of upcoming topics of physics. So let's start, students. You must remember that in the previous chapter, that is of kinematics, we've discussed various types of motions or movements shown by different objects. But we didn't discuss the causes of that motion, of those motions. That part was left. So, talking about motion without their actual causes does not sound good. So in this chapter, we'll discuss different motions and what causes that motion in certain objects to happen. So, dynamics is the branch of mechanics that deals with the study of motion of an object and the causes of its motion, or study of forces and their effect on motion. So, regarding this, Isaac Newton defined the fundamental physical laws which govern dynamics in physics, especially his second law of motion. So, there are basically three terms important in this chapter that we'll discuss in the upcoming slides. That is force, inertia, and momentum. So, let's discuss force. In science, force is the push or pull on an object with mass that causes it to change velocity or to accelerate. Or we can say that a force moves or tends to move, stop or tends to stop the motion of an object, or can change even the direction of an object. Means a force can change the motion of any object, either it is at a stationary position or moving with a uniform acceleration, or can also change the direction of that object. So as you can see in the first example, this man is trying to push this heavy cupboard or almirah by applying a force, whereas there is another force acting on this object that is known as force of friction, also known as resistance. This type of force, that is friction, is always acts in the opposite direction of the force that you are applying. In the second example, as we have discussed that a force can also change the direction of an object, so here in this case, the ball changes direction and moves away from the batter. Or in the third example, when released hydrogen balloons rise up in the sky, this happens because of the force that is known as upthrust. Or in the fourth example, as we all know, gravity. So, gravity tries to pull everything downwards. And so is the case with this apple. Therefore, force represents as a vector, which means it has both a magnitude and a direction. So now let's discuss some of the types of forces. Basically, the types of forces have been divided into two categories, that is, the contact forces and non-contact forces, or known as forces at distance. So contact forces is interaction between objects that touches. Whenever two things interact or more than two things interact with one another, you will see a contact force phenomena there. Whereas in non-contact forces case, the objects attract or repel even from a distance. So some of the contact forces are applied force, as you can see in this, a spring force, drag force, frictional force, and the normal force. Whereas magnetic force, electric force, and gravitational force are termed as non-contact forces. Now students, let's see some practical examples of force and the types of force, so that it will be much more clear to all of you.
Force and motion.
Wow. I'm okay.
How does an avalanche occur? What sets things in motion? What causes motion and what stops it? Forces. A push, a stretch, a pitch, the attraction of a magnet, a touch, all these are forces. A force is a push or attraction exercised by one object upon another. As the force of the wind on the blades of a windmill, the attraction between two magnets, an ox pulling a wagon, or your foot kicking a ball. A force would not exist by itself because it is an interaction. What this means is that it depends on the relationship between various objects.
Ah! All the things that surround us exert forces on each other, and this is constantly happening.
Some forces act in tiny things, such as those joining the water molecules to form a drop.
And other forces act on humongous things, such as those governing the motion of the planets.
Forces affect the shape and motion of all things. They can trigger the movement of an object, speed it up, change its trajectory, stop it, or just keep it still. Forces can do that through contact, when objects touch each other, but they can also do it at a distance, such as in magnetism, electricity, or the force that keeps us glued to the ground. Do you know which force that is? Every time something moves or changes its shape, there are forces at work. And when nothing changes, forces are at work too, offsetting or overriding each other.
And what forces would cause an avalanche? Oh, okay. Did you know that right now there are forces at work around you, keeping you still? Or are you actually moving?
Now students, let's discuss another very important term known as inertia. So what is inertia? Inertia of a body is its property due to which it resists any change in its state of rest or motion. Or we can say a tendency to do nothing or to remain unchanged. So inertia is basically the resistance force exerted by every object. But it solely depends upon the mass of the object. If the object is heavier, means it has greater mass, then it has greater inertia, and vice versa. So, mass is that quantity which depends solely upon inertia. Let's discuss some of the experiments that can prove this property of objects. You can also do these experiments at your home. In first example, place a paper with a coin on it onto a filled glass. Then gently try to remove the paper. What do you say? Will the coin move as you remove the paper from between the coin and the glass? No, it will not. Why? This is because of the resistance property of coin, known as inertia. In our next example, all of you must seen this magic in your early ages. The magician moves the tablecloth gently from the table, and whatever the cutlery was on it remains in the same condition on the table. This is also because of the property of inertia. Or, if you try to remove gently one book from a huge pile of books, the books will not fall. This is also because of inertia. Let's see one practical example or experiment of inertia so that this concept will be much more clear to all of you. As this concept is very important, that is, the concept of inertia is very important in understanding the Newton's first law of motion.
All right.
That's the one I would have picked. Perfect. All right.
You know what? I
That's
dented
great.
that one a little
Yes,
bit.
no, that's okay. That's
Here's
okay.
one. There's a
That's
perfect one.
perfect. All right. So if I let you just drop the egg in, don't. Gravity would be the winner, but you don't want to do that. It's too easy.
Oh, well,
all right.
of course.
So that's why the pie pan is here. So the pie pan's going to go in place. Got that? And now above the here's what you how good you were. No, it's okay. You've got 11 more tries.
You may see a lot of that before it's over.
Please, no problem at all. Hey, wow, this segment's going to go well, I can tell. All right, when you put your hand here and you hit the pan out of the way, you're going to transfer the energy to the egg and pop it up in the air. And given your little mistake right there, you scare me already, all right?
I'm going to do that?
No, let's use the do to do
Oh,
too.
good,
All right.
okay,
So
good.
all right. So this is going to go here, and now the egg is going to go on the top.
Oh, well, this
okay?
makes it so much
so
better.
much easier. All right. So here's what you're going to do. Your hand is going to go here. You're going to pull back about this far. You're going to hit the pan straight in. That pan's going to move. It's going to knock the tube out of the way. The inertia of the egg is going to hold it there for just a second. Bam! Falls right into the glass.
And this is going to happen.
Well,
not done this
given
one
your
before.
success over here, I think that
Not
should be
too
just
good.
fine.
You should
all
be
right?
apprehensive.
No,
I
I
am.
think you're fine. All right. All right. So the hand's going to go right here.
I give it a
okay.
good-
Yeah. Don't knock over the glass, but you're going to give it a little pop. Ready?
Okay.
Here we go. 3, 2, 1. Give it a pop.
Oh!
Nice. That was good. See?
Thank you very
now,
much.
When we instant replay, you're going to. That was you. You
That
got
was-
luck.
that was
That
good.
was luck on this
Oh,
one.
that
This
was
is good.
luck.
That was good. And so here's what we're going to do. And you commented the last time that we talked about this that I don't ever have to do it. So I'm going to try
That's
it.
excellent.
all
I
right?
think it should
All right.
be
So
you.
I'm going to give it a try. So
How
was.
often do you actually get all 5 in?
I've never
You
done
know,
this
you've
before.
never done
So
it
yeah,
before,
but in a
of course.
dream, it came to me like this, and
Oh,
I read
gee.
about it on the internet. No, I don't know. All right, so here we go. There's. You just have to get right over the top,
all
and
right,
this is one of
okay.
those things that you say, "I'm not going to do this at home. I'll do it at a friend's home." Got it?
Right.
All right. So here we go. This one's here, and here, and here. Nice.
No logic in using boiled eggs for any of
No,
this.
why would you?
No.
Why would you? All right.
Okay,
All
I'm
right?
going to stand
All right.
back. Just
I think you're going to be just
parsec
great.
or two
All right.
here.
All right. So no, come on over here and enjoy. All right. So when we pull back like this, we just try to just pop it out of the way and see if we can get them in. Ready?
Okay,
5
ready.
in. Here we go.
All right.
3, 2, 1. Look at that, people. That's 5.
Man,
Is that awesome?
that is phenomenal.
So students, you can see that this all happens because of the property of inertia contained by every object. And this solely depends upon the mass of that object. The heavier the mass, the greater the inertia. The lower the mass, and the lower will be the inertia of that object. Now let's move on to our next topic, that is momentum. It is also a very important term that you should understand. So momentum of a body is the quantity of motion it possesses due to its mass and velocity. Means how much change occurs in the body due to the force that has been applied on it. So momentum is a vector quantity, whereas it is the product of the mass and the velocity of an object or particle. Mathematically, it is represented as P is equals to m dot v. M represents the mass and v represents the velocity, whereas momentum is the product of these two terms, that is mass and velocity. Whereas mass and velocity are inversely proportional of each other, in such a way that if the object has a greater mass and when a force is applied on it, due to its heavier mass, it will attain lower velocity, and vice versa. That is, if the mass of an object is small or less, then when the force is applied on it, the object will move with a higher velocity. So, the standard unit of momentum magnitude is the kilogram meter per second, or it is represented as kg meter per second, or in this way you can also write it. Kg represents the mass of any particular object, and meter per second represents the velocity attained by that object when a force is applied on it. So, dear students, let's understand this term, that is momentum, with a practical example.
Imagine you are on a treasure hunt, and after months and months of searching, you have found the lost temple and can finally loot all of the treasure. But as you try to do that, you realize that the chest is behind a huge glass wall. To make matters worse, your arch rival is also there to grab the gold, and he has a giant rock to help him. You only have a marble in your pocket. What should you do to break the glass wall and take all of the treasure? Let's see your rival's plan. If he rolls the rock, the glass will easily break. Can you roll your marble and expect the same thing to happen? That might not work for you, but why? An obvious difference between the marble and the rock is that they have different sizes. To be precise, they have different masses, and the heavier rock is the one that is able to break the glass because it applies a larger force on the wall. What you've just figured out is that the force applied by an object depends on its mass. So using the rock, the glass will break easily and your rival might win. But now the pressure is on you. How can you break the glass with a marble? While thinking, suddenly you have an idea. You check your other pocket and find a toy gun. Would shooting the marble break the glass? This plan might definitely work. But why? Because now the marble would have a much greater speed. A greater speed will result in a greater force on the glass wall, and it would break. From this plan, you realized one more important factor that affects the force applied by an object: its velocity. If you combine the two things you've just learned, you can say that the force applied by an object depends on its mass and its velocity. What you've just figured out, Newton had discovered a long time ago. He felt that if we combine mass and velocity, we can talk about force and actually calculate it. This gave birth to the concept of momentum. Momentum gives us a better idea about force. Let's see how. For an object with a mass m and velocity v, momentum is given simply as their product. We denote it by the letter p. So p is equal to mv. So the rock had more momentum because it had a greater mass. The marble had more momentum because of its higher velocity. And because of this large momentum, both were able to break the glass. We can use momentum to understand a lot of other things. For instance, ever wondered why a fast bowler takes such a long run-up when he bowls? Long run-ups help him gain velocity. What he's basically trying to do is gain momentum. This momentum helps him bowl faster. This same technique is used in many other sports like the javelin throw. The athletes take a run-up to gain momentum, and this helps them throw the javelin as far away as they can. Now that both you and your rival understand what momentum is and how it works, how about you both break the glass together and split the treasure equally, so everything's fair? I'm sure you're happy you learned these today. Force applied by an object depends on 1. The mass, and 2. The velocity. P is equal to mv. Momentum, the velocity. P is equal to mv. Momentum equals mass into velocity. But you're probably happier because now you're rich, and maybe your rival will become your partner.
I hope students, your concept about momentum are now clear. Let's move on to our next topic. That is about Newton's law of motion. The very important laws of motion, or very important laws of physics. So, Newton was the first to formulate the laws of motion, known as Newton's law of motion. There are basically three types of laws of motion. First law of motion states that every body remains in a state of rest or uniform motion unless acted upon by a net external force. Second law states that the amount of acceleration of a body is proportional to the acting force and inversely proportional to the mass of the object. Whereas he derived a formula for this force is equals to mass into acceleration. And the third law states that for every action there is an equal but opposite reaction. If an object A exerts a force on object B, then object B will exert an equal but opposite force on object A. As you can see, these all laws practically in these examples. We'll discuss these three laws one by one in our upcoming slides. So, let's discuss first the first law of Newton, that is also known as law of inertia. So, Newton's first law of inertia, also known as Newton's first law of inertia or law of inertia. So, as we have discussed, that inertia is basically the tendency of an object to resist a change in motion. Or, inertia means that the object's motion will stay constant in terms of speed and direction. And we have also discussed that inertia solely depends upon the mass of the object, whereas it does not depend on the presence of a gravity. For example, an object's inertia is same on the earth and in space. So what basically Newton's first law of motion says that an object at rest will remain at rest, or an object in motion will continue with constant speed and direction until and unless it is acted upon by an unbalanced force which change its stationary motion or a stationary condition, or change the direction of the object. So one of the most common example in our from our daily life is whenever you are sitting in a car and driving with a very high speed. So there you experience the Newton's first law of motion. So when you apply the brake, your car stops. So an outside force stops the vehicle, but you, as a passenger, moving at a high speed, are not stopped and continue to move at the same speed, and therefore you experience at once a jerk. Or when you apply the accelerator of your car in order to move again, you again feel a jerk. This is because you were at a stationary position, whereas your car starts to move. And due to the property of inertia, you feel or you experienced a jerk. Now students, let's try to understand this Newton's first law of motion with another example. I hope you will enjoy it. And after that, your concept will be clear about this topic.
Yeah!
As we all know that Sir Isaac Newton was one of the greatest influential scientists of all times.
Ah.
Huh?
So, an object will continue to remain at rest, or uniform motion, unless it is acted upon by an external force which will try to change the position of that object.
Ah.
But due to the force of inertia, these balls will be unable to move themselves unless acted upon by an unbalanced force. So, the law also states that the ball will stay in a state of constant velocity in the absence of an unbalanced force. This means if there was no frictional or any other force, the ball would continue to move in the same acceleration with the same acceleration. But what happens here is this ball ultimately stops. Why this happens? This is because of the force of friction. Which will resist further motion of the object. Now students, let's discuss the Newton's second law of motion, which states that when a net force acts on a body, it produces acceleration in the body in the direction of that force which has been applied on it. The magnitude of this acceleration is directly proportional to the net force acting on the body and inversely proportional to its mass. Or we can also say that an unbalanced force causes an object to accelerate. The acceleration of the object is equal to the net force acting on it divided by the object's mass. So, as you can see here in these two instances, that an unbalanced force is applied on this object in the same direction. So, when two forces act in the same direction, the net force is basically the sum or the total of the two individual forces, and hence resulting in a greater force. And due to this greater force, the box or this object will move in the forward direction or in the direction in which the force has been applied on it. Whereas in this instance, force is also applied on this object, but in the opposite direction. One from the right side and the other from the left side. So, what will happen in this case? Will this object be able to move? No, because both the forces will cancel each other's effect. Or, when two forces act in opposite direction, the net force is the difference between the two individual forces. The box moves to the direction where the force is greater. For example, if the force applied by this boy is greater than the force applied by this girl, So the object will move slightly towards the right. So Newton's second law of motion depends upon two factors, that is mass and acceleration of a particular object. As we know that acceleration is produced in an object when an unbalanced force acts on it, and if the greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. So, force or the net external force of an object depends upon the mass of the object and the acceleration of the object. Means the product of mass and acceleration will be equals to force. As you can see here in these two instances, that this person is trying to move the small ball from, for example, position A to some position to point B. So, as the mass of this ball is very small, so the force that will be applied on it will cause this ball to move with a greater acceleration because its mass is very small. Whereas if the same person tries to hit this big car or a truck, so what will you say? Will he be able to move this car? No, he won't, because this car or this truck has a greater mass, due to which it will have less acceleration. Remember that in both the cases the force is same, but the masses of the objects in the two instances are different. The object with a smaller mass will have a greater acceleration, whereas the object having a greater mass will have a small acceleration when equal forces are applied. So here's a question for you all students. Keeping in view this formula, for example, this object or this car weight mass is 1000 kg and it is moving with an acceleration of 0.05 meter per second. So what will be the force here applied by this person? You can find this by using this formula. F is equals to ma. Putting the values, that is mass is equals to 1000 and acceleration is 0.05. So whatever the product, whatever will be the answer of these two values will be equal to the force that this person have applied. Right? Try to do this question right now. I hope you've got your answer. So now let's discuss one question related to this topic. But students, before starting this question, let's see a practical implication of the second law of Newton, so that it will be much more clear to all of you. So, Newton's second law states that the rate of change of momentum of an object is directly proportional to the unbalanced force in the direction of force. As force is proportional to the final momentum minus the initial momentum divided by the time. So we know that final velocity minus the initial velocity is equals to the acceleration. So substituting the value here, we will have force is equals to, or force is proportional to, mass and acceleration. So as you can see here that as the force has been applied in the forward direction, therefore the horse is moving in the forward direction. So as here in this case, Newton applies less force, and due to which less acceleration has been generated. Whereas, as we all know that horse is more powerful, so his force will be much greater than the Newton's force, and the acceleration produced by the force will also be greater. Hence we can say that force is proportional to acceleration. So here we can see that as mass of Newton is smaller, so the force which has been applied by him is also smaller. Whereas horse is more powerful because of its mass, and therefore the force applied by him or exerted by it is also greater. So, by this, we came to know that force depends upon the mass and force depends upon the acceleration. And hence we have derived the formula that force is proportional to mass and acceleration. So now let's discuss this question. A force acting on a body of mass 5 kg produces an acceleration of 10 meter per second square. What acceleration the same force will produce in a body of mass 8 kg? So here in this instance, we are given with the mass of the first object as 5 kg and the mass of the second object is 8 kg. And the acceleration in the first object is 10 meter per second square, whereas the acceleration of the second object is unknown. And the force applied on the objects is also unknown. But in the question, we are given that the force which has been applied on both the objects in order to accelerate them is same. So we have to find the acceleration of the second object, keeping the force constant. So the formulas that we will use here are force is equals to, as the same formula, F is equals to ma. So F is equals to m1 a1 and F is equals to m2 a2. Now moving towards the solution of this, using the first formula here, F is equals to m1 dot a1, dot means the multiplication, which is equals to, now we'll put the values that we were given in the question, that is 5 kg multiplied by 10 meter per second square. We will get the force as 50 Newton. So there are basically two ways by the help of which we can solve this problem, or they can also be more, but I have solved this question by this way. So we have found the force that has been applied on both the objects, as we were given in the question that force is same for both the objects to accelerate. So I decided to find the force first, which is 50 Newton. And now, in order to find the acceleration of the second object, we will use this formula, F is equals to m2 a2. So, substituting the values, putting the values, 50 Newton force is equals to mass was given as 8 of the second object, 8 kg, and the acceleration was unknown. So we will write it as it is, a2. So keeping in view the mathematical way of solving this question here, we will move 8 towards the left. So 50 divided by 8 is equals to acceleration, as we have to find the acceleration. So we will separate it from all the other given values. And when we'll multiply it, we will get the answer as 6.25 meter per second square, which is basically our acceleration of the second object. We can also write this as in this form, acceleration of second object is equals to 6.25 meter per second square. Whereas in your textbooks, this question has been solved with another pattern. That is, F is equals to m1 a1 and F is equals to m2 a2. We have compared both the equations, as we have discussed that the force applied here is same. So comparing both the equations, m1 a1 is equals to m2 a2. Now putting the values, mass is 5 kg of first object and the acceleration is 10 meter per second square. Mass of the second object is 8 kg and the acceleration in the second object is unknown. So we will write it as it is. and by solving this whole term we will get the acceleration as 6.25 meter per second square. So this is another way we can solve this question. So now let's discuss another topic, which is last but not the least, comparison of mass and weight. So in the first comparison, or the first difference in between these two, is mass is a property of a matter. The mass of an object is the same everywhere, whereas weight depends on the effect of gravity. Weight varies according to the location. And this is because this is how, if you weight your body weight, so if you weigh your body weight, so for example in Quetta you will find another reading, and when you will measure in another place, let's say Islamabad, so there your weight will be different. Why? This is because of gravity. Weights consider the force of gravity, right? Second is mass can never be zero, whereas weight can be zero if no gravity acts upon an object, as in space. For example, as you can see here, that the mass of this astronaut is 100 kg on Earth, whereas if he goes to the moon, then his mass will same as 100 kg. But when he weigh his weights, so his weight will be 980 Newton on Earth, and on moon it will be 162.2 Newton. Why? This is because of the force of gravity. On Earth, the gravity is very high, whereas on moon it is very low, equals to 1.6 something meter per second square. The third difference is mass does not change according to location, whereas weight increases or decreases with higher or lower gravity. For example, your weight will be different on plain areas, or and your weight will be different on the higher places, for example on mountain. Fourth is mass is a scalar quantity. It has magnitude, and weight is a vector quantity. It has magnitude and is directed towards the center of the earth or other gravity well. Fifth, mass may be measured using an ordinary balance, whereas weight is measured by using a spring balance. And the sixth difference is mass usually is measured in grams and kilograms. Weight often is measured in Newton, a unit of force. So, the formula which we'll use in order to find the weight of any object, the formula is W is equals to mg, mass of the object as well as the gravitational force acting on the object. So, keeping in view these two terms, the unit of weight will be Newton, and Newton is equals to kg meter per second square. Kg for mass and meter per second square for the gravitational acceleration. To conclude, we can say that we have discussed in our today's lecture the introduction of the chapter, then force, inertia, momentum, and Newton's first law of motion and Newton's second law of motion. In the next class, students will discuss Newton's third law of motion in a bit detail. So I hope your today's lecture is clear to all of you. Looking forward for your positive response. Till our next lecture, take care of yourself a lot, and thank you.